Hi guys, and today we're gonna learn about some 7th grade math here with about how to figure out if a triangle is similar or not similar with using strategies like SAS, SSS, and AA. So first I'll break down what does it mean by triangles or similar. For this, I'd like for you to know another vocab word that's meaning is um is congruent. So for the meaning to be congruent, so we're gonna first look at congruent. Okay, so congruent is meaning is basically that it's the same on two triangles, because they were talking about triangles. It's a geometry lesson. So the same on two triangles. This could go for side shape. This could go for side shape or angle. So for any of this, congruent basically means that it's the same for two triangles. So what does similar mean? Similar means that it's the same triangle but bigger. So similar means that you can find out. That's why you're trying to find out if something is similar, is because if you find out if it's similar, then you know that it's the same triangle, just a tad bit bigger. So similar means that it's also proportional. Similar also means that similar, on the other hand, means that it's proportional, and proportional means that it is and proportional means that you just have to change it by a number. You just have to do an equation to change it. Like for an example 10 and 5, see, they're the same. If you just divide them both by 5, you'll get a 2-to-1 ratio any day of the week. So here, now let's get started on the equations: SAS, SSS, and AA. So we're gonna first look at some SAS. Okay, so I know it sounds weird, but SAS, which stands for side angle side. So for SAS, let's say we're looking at two triangles like around this. Now I'll redraw that because my drawing skills are not the best in the world here. So let's say these two are here. It's not exactly to scale, but you'll be able to get the idea. You will know two sides, 10, and that will be 5. Let's say they're both centimeters. So SAS is an easier one. You don't need to solve anything. Here it's 5. You do need to solve some stuff, but not really much. And let's make the 5 a 6. 6 centimeters. And here, let's say it's 5 and I wrote it upside down, I think. And 3 cm and 5 cm. Okay, so here it's an important thing to say. This also goes for SSS, especially for SSS. It's really important that you only look, and I know it's thick, but this and this. Right? You aren't going to go from 10 to 3. You have to remember that. You stay from the same side. This side and this side, they're both the same side on the triangle. Right? They're both this side on the whole triangle. Correct? So, now if we see 10 and 5, like I said with the example 10 and 5, so we can just put 10 on top of 5, and here if you really want to be proper, you can also say A, B, C, D, E, and F. So it's 10 over 5. You could say AB over DE equals to 2, or 2 over 1. So that's important, and we'll know the one angle that's between them. Let's say that's around 60 degrees. Same here. 60 degrees. So it's 2 over 1. And now this other side, it's 6 and 3. Now just put them on top of each other and you get the same thing, 2 over 1. Now, that's the two sides we know. We figured it out. Now let's look at the angles. Both the angles are the same. So that means check it off. I just wrote sim, but it's similar. You can check it off. Now let's go to another problem. That was SAS, if you want to remember that. And now we're going to go to SSS, side, side, side. Now we're looking at side, 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 which is a whole different, it's not too different of a topic, but it's quite different. Honestly, side, 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 I really like it. It honestly makes the most sense about why it works, but they all work. So it's side, side, side. Here you do the same thing with the two sides you did in SAS, but this time you're just not gonna have an angle, and you're gonna do all three sides. So let's say that's 2, 4 now. Let's make that. Let's make that 4. Let's make that 8. Let's make that 5, 10, and 3, and 6. So, alright, accidentally wrote it wrong, but you could see here that this triangle and this triangle are there. So let's say that's 3, 9, 2, 6, 4, 12. Well, those two would have to be the same if saying it's an isosceles triangle, so they'd both be 9. And so now we instantly know that there are 2 3's here. So this 3 go with that, and this 3 go with that. And we can just go quick. 3 over 9 equals to 1/3. So we know this side's good, this side's good, and that side's good, and that side is good. Now the question comes to that one bottom side. It's really the deciding factor. Now we're gonna look at 2 over 6, divide them both by 2 is 1/3. I know this is taking long, but we're nearly done. So 2 over 6 is 1/3, 3 over 9, both sides, 1/3, 1/3. Now that we've checked all three sides, they're all 1/3. That means it's similar. And yes, if it's not similar, if they're both not 1/3, let's just say this, it was a different scenario, and this was 2/3, then it would be not similar. But in this case, it is similar. So it doesn't always have to be used to figure out what is similar. If it doesn't follow the rules of what needs to be similar, then it's not similar. So angle. This is the last one. And this is the easiest one for you to identify. So here, let's say this and this exists, and we know that is a 90-degree angle. Let's say that is a 50-degree angle. That's all they're giving you, but now you know that that is obviously a square, so it's a 90-degree angle, and that is also a 50-degree angle. And because these two are equal and those two are equal, we know it's similar. Angle is the most easiest way to figure out if two triangles are similar, but that's all we have. This was how to figure out if a triangle is similar. And we learned about similar, we learned about congruent, which means the same. So you can say that this and this are congruent. You could say that, or cong. Otherwise, or if say these are both 8 and this is 8, these are also congruent or the same. That'll be the wrap, guys. Bye.